Hello everyone. Today me, your friend Krishna Kumar Chaudhary from Viratnagar came with the new content, that is differentiation of a function. Our content is differentiation differentiation of a function. No? Differentiation of a function. So let's come with the definition first. So what is the definition? A function fx, a function fx is said to be differentiable or derivable no, at some point, that is, say that point is a, if for h greater than 0 you should have limit h tends to 0 f a plus h minus f a, and then by h, which is equal to limit h tends to 0 no f a minus h minus f a by minus h. That is, what does it mean? This one left side is called right hand derivative, and that must be equal to left hand derivative. Now if it will happen so, then it is called differentiation of a function, and it is denoted by f dash x, no, or you have a point a, no, f dash a, you can say f dash a, or you can say df by dx at that point, no, at that point. Okay, and after differentiation this, then let's come to the problem first, and then we will go to the theorem questions. We have a function f is defined as follows. Okay, you have given the function as follows. What is the function? Fx is given as a 2x plus 1 when x less than 1, and next in the domain 3 when x is equal to 1, and lastly you have a function that is x square plus 2 when x greater than 1, in the domain x greater than 1. So you need to find f dash 1. Question is asked to you, find f dash 1. Your target is to find f dash 1. Okay, for that what you need to find? You need to check the differentiability at point 1, and if both will be equal, that will be the f dash 1. So let's now solution for this. You need to find the right hand derivative for it. So at what point? At x equal to 1 you are going to check it, no, whether it is differentiable or not. If differentiable, obviously that will be your value. So first is right hand derivative, that is limit h tends to 0 f, you have a formula a plus h, no, a plus h minus f a, and then by h. So instead of a you have given 1, substitute it, limit h tends to 0 f 1 plus h minus f1, no, f1, and then by h. Just substitute it in the right hand derivative. What you have? Obviously the domain is this one, no, for that what you have? Function x square plus 2. Just instead of x you should substitute 1 plus h, no, instead of x. Okay, fx is given your x square plus 2, then what will be the f1 plus h? Just instead of x you have substituted 1 plus h. So 1 plus h will be, instead of h, 1 plus h of whole square. No, limit as it is, limit h tends to 0. No, 1 plus h of whole square, 1 plus h of whole square plus 2 is there, plus 2, 1 plus h of whole square plus 2 function, and then f1 you have given value minus 3 and by h. Okay, this is, no, just instead of x you have kept 1 plus h of whole square plus 2 as it is, and f1, what is in the domain f1, x equal to 1 case you have a function 3 and by h. Just compute it, limit h tends to 0 h it is, and 1 plus h of whole square is 1 plus 2h plus h square, and after subtraction you will get minus 1 and by h. Then 1 and 1 will be cancelled, remaining what will be the limit h tends to 0. No, h tends to 0, and if you will divide by h, what you will get, 2 plus h you will get. No, after dividing with h, 2 plus h, substitute this, that you will get 2. Means right hand derivative you found how much, 2. Now let's compute the left hand derivative. No, then we can say derivative exists, and that will be your value. Okay, now your target is to find left hand derivative. So now left hand derivative, for that case left hand derivative, which is equal to limit h tends to 0, formula you have f a minus h minus f a and by minus h. This is your formula, and instead of a you should substitute the 1, limit h tends to 0, f 1 minus h, no, and minus f1 and by minus h. No, in the left hand derivative, in x less than 1, for the domain x less than 1, what you have, function 2x plus 1. For the domain x less than 1, you have a function 2x plus 1. Instead of that, fx is given 2x plus 1. Then what will be the f1 minus h? Just instead of x, you should substitute 1 minus h. So 2 times 1 minus h, no, 2 times 1 minus h and plus 1. Okay, plus 1, and f1 value, f equal to 1 case you have minus 3. Okay, f3, f1 value is 3 and by minus h, and here you have limit h tends to 0, h tends to 0, this is equal to, no, and compute this one, limit h tends to 0, just multiply 2 minus 2h plus 1 minus 3 and then by minus h, which is equal to limit h tends to 0. Then what you will obtain, obviously 2 1 3 3 and minus 3 0, then you will obtain minus 2h by h. So what you will get, limit h tends to 0, then what you obtained, this is minus h, no, obviously you will get minus 2, h cancel, then 2 you will get, which is equal to 2. That means what did you get? You got what did you get? You got how much? That is since right hand derivative equal to left hand derivative, no, so differentiable exists, so we can say differentiability exists. Differentiability exists, no, we can say that differentiability exists, and therefore what do you have, f dash 1, which is equal to 2. This is your required answer for this. No, in that way you can find the differentiation at a point. So now after this you have one of the theorem. So theorem we can say, one of very important theorem. After then one problem we will take, then will be completed for this section. After this you have one theorem. What is the theorem? That theorem is differentiability Okay, differentiability of a function fx at x equal to a implies continuity. Okay, implies continuity, but converse may not be true. But converse may not be always true. Be always true. This is your theorem. Okay, for let's prove this. Every differentiable function, that means what? Every differentiable function is continuous, but every continuous may or may not will be differentiable. Okay, may will be differentiable or may not will be. So converse may not always be true, means every time there it is not possible that every continuous function is differentiable. May or may not be always true. So for this, let's prove it. Suppose that, first of all, suppose that function is differentiable. Okay, suppose that function is differentiable. Suppose function is differentiable. Function fx is differentiable at x equal to a. Suppose the function is differentiable at x equal to a. What does it mean? You have suppose differentiable. Now you need to prove the continuous. Okay, you need to prove continuous at x equal to a. Suppose you have suppose differentiable means what? That means right hand derivative is equal to left hand derivative. Obviously both will have the equal value. Say that has a finite value. No, a finite. What does it mean? Right hand derivative means limit h tends to 0 f a plus h minus f a and then by h, and left hand derivative means limit h tends to 0 f a minus h, okay, minus f a and by minus h, which is equal to a finite value. This is, you have supposed this. Your target is to prove continuous. Okay, and for that, what you need to show? We need to show that fx is differentiable. Continuous at x equal to a. Your target is to show continuous. Okay, for that, okay, you will take this part. We know that f a plus h minus f a, upper part of this numerator part, okay, which can be written as f a plus h minus f a, and by h into h you can write. No, you can cancel it, it will remain as it is. No, taking limit on the both side, taking limit h tends to 0 on both sides. What will you obtain? You will obtain limit h tends to 0 f a plus h and minus f a, which is equal to limit h tends to 0 f a plus h minus f a and by h, and here also you can take the limit into h as it is, no problem. Let's separate the limit h tends to 0 f a plus h minus limit h tends to 0 f a, which is equal to limit h tends to 0 f a plus h minus f a and by h into limit h tends to 0 and then h. Then what will we have? What will be limit or limit h tends to 0. Okay, limit h tends to 0 f a plus h minus, if you don't have h here, as it remains as it is, which is equal to the value of this is a finite value and into h tends to 0 you will keep then 0. Then what you will obtain? Limit h tends to 0 f a plus h minus f a. If you will multiply with 0 a final value then 0. That means or limit h tends to 0 f a plus h. You can take this right side f a. This is called as a limit x tends to a positive of fx, right hand limit, which is equal to functional value f a. Suppose this is 1. Now what you obtain, that right hand limit is equal to f a. For the continuous, you know that right hand limit and left hand limit and functional value, all three are the equals, will be equal. No, so for that, now similarly, after then similarly we can show that limit h tends to 0 f a minus h, which is equal to f a. That means what? Therefore limit x tends to a negative fx, which is equal to f a. No, this is second. Okay, what you did, this one was first, this is second. No, and then this is your third. Then from second and third, this is equal to this. Fa is equal to left hand limit and Fa is equal to left hand limit and right hand limit. No, therefore thus from 2 and 3, from 2 and 3 you will obtain what? That is limit x tends to a positive fx, which is equal to limit x tends to a negative fx, which is equal to fa. All three will be equal due to functional value are equal. No, thus hence fx is continuous at x equal to e. No, first part, necessary part is you are proved. Now your target is to prove the converse may always not be true. No, okay, conversely, converse part you are going to prove. Conversely, to show the converse part, converse may not be true, we consider one of the function, consider fx is equal to modulus x. Okay, one of the function you have considered fx equal to modulus x. We shall show that fx is, for that function you will show fx is continuous. This function, which you have considered, okay, modulus x is continuous at x equal to 0, but fx is not differentiable. But fx is not differentiable, at x equal to 0. Your target is to prove the function is continuous at x equal to 0 for that function and not differentiable for the given which you have considered functions. So now at x equal to 0, how will you prove the continuous? Obviously you will take the right hand limit. No, right hand limit, which equal to limit x tends to 0 positive for 0 fx, which is equal to limit x tends to 0 positive for that function we have given function modulus x. If you will substitute the value, obviously 0 positive of modulus, which is equal to 0. Oh, this you will get. And left hand limit, what you will get? Limit x tends to 0 negative of fx, which is equal to limit x tends to 0 negative of modulus x. If you will substitute this value 0 negative, what you will get? Though you will get 0. And lastly you will find the function f0, which is equal to modulus of 0, which is equal to 0. And what you got? Thus fx is continuous at x equal to 0. No, you got this one. How? Because the right hand limit equal to left hand limit equal to functional value f0. No, so due to that, function is continuous at x equal to 0. Now your target is to prove the function is not differentiable at that same function which you have considered this modulus x. No, your target is to prove the function is not differentiable for the which you consider a function. No, so for that you need to, for differentiability at x equal to 0, for differentiability at x equal to 0, this you are going to check it. Now for that you need to find right hand derivative, which is equal to limit right hand derivative definition is s tends to 0. Instead of a you should substitute 0 plus h minus f0 and by h, and which is equal to limit h tends to 0. Obviously you will get fh means if you will substitute fx equal to model, your function is what? Fx equal to modulus x. No, fh means modulus h minus f0 means 0 and by h. That means limit h tends to 0, this you will get h by h which is equal to 1. And similarly, and left hand limit, what you will get? Left hand derivative, you are talking about derivative, which equal to limit h tends to 0, f0 minus h minus f0 and by minus h is your definition, which is equal to limit s tends to 0, f minus h minus f0 only will be by minus h. If you will substitute what you have given function, the function is fx equal to modulus x. If you will substitute there f minus h, what you will obtain? Limit s tends to 0. No, obviously you will obtain minus h modulus and minus 0 by minus h. If you will take out from the modulus the minus h, obviously you will get the positive h tends to 0, h by minus h. What you will obtain here? Minus 1. Since what you got? Since at x equal to 0, that you obtain right hand derivative is not equal to left hand derivative. Now fx is not differentiable. Not differentiable at x equal to 0. No, the function is not differentiable at x equal to 0. No, hence you can write the statement. Okay, here you can write the statement. What was your statement? The differentiability of function fx at x equal to a implies continuity, but converse may not be always true. That statement you can write, and you can write here proved. Okay, in this way you can prove the differentiability of a function is continuity, but converse may always not be true. Let's come to the one problem after then over. Or you can complete, I think. No, you can complete yourself. No, you can complete the exercise 1.5. you can see here, examine the continuity of function at a specified you have here what does it mean? This one function minus infinity less than x less than 0. This means 0 less or equal to x less than pi by 2. This means pi by 2 less or equal to x less than infinity. Okay, you can complete that yourself. You can complete. Okay, thank you. This much for today. You have problem this side even, you have problem here even, you can complete yourself. Okay, thank you this much for today.